Let's ask some people about their favorite dish. Hi, can I ask you some questions?
Sure.
May I have your name first?
My name is Gusti.
Hi, I'm Celia. Saya Budian.
Okay, so we want to ask you, what's your favorite dish?
I would say my favorite dish is ranging from chicken meat to fish meat. I love all of them.
Kan dong. Wait, I want to search first. Fish.
Do you like a fish or not? Yeah, I do.
Why is that so? Why do you like fish?
Fish in particular because I think it's very popular here in Bali, especially tuna. Tuna is very popular in Bali, and I love it because it's so delicious.
That's cool. I like fish too. Thank you.
No worries.
As of 2021, each individual in Indonesia consumes approximately 35.26 kilograms of fish a year. The fish consumption per capita in Indonesia was forecast to slightly increase by around 0.15 kilograms per capita in 2031, around 8 years from now. Compared with other sources of protein, such as chicken or poultry meat, it only consumes around 8.05 kilograms per year. So, we can assume that we actually eat more fish. Maybe thanks to our geographical features as an archipelago consisting of more than 17,000 islands with 5.8 million square kilometers of the maritime area. We are one of the most fish-dependent nations in the world.
Okay, enough of the number and statistical things. Now you might start wondering, what's all this about? Do you know that nearly all fish and shellfish contain traces of mercury? If you've never heard of it, mercury is a naturally occurring element, a heavy silvery white metal. It may have toxic effects on our body, our digestive, nervous, and immune systems, our lungs, kidneys, skin, and eyes. According to WHO, it is one of the top 10 chemicals of major public health concerns. Mercury can contaminate us through our lungs, skin, and mouth. One of the most common ways we're exposed to mercury is by eating food that contain the compound. Now, do you know that there is no method of cooking or cleaning that can reduce the amount of mercury?
So, how does mercury get into the fish? When mercury is present at a water body, it is converted into metal mercury by bacteria and other processes. Then, it is taken up by plankton, which is what small fishes eat. The mercury will be tightly bound to protein in all fish tissue, including muscles. For your information, metal mercury can also contaminate fish from the water as it passes over their gills. Large fishes then eat many smaller fishes, and at last, we humans consume the fish. We can see that the metal mercury accumulates as we move up the food chain. Before that, how can mercury be present in the water? There's a lot of possibilities since there are multiple sources of contamination. One of them is the burning of fossil fuels, especially coal, which releases mercury into the air before it gets washed into the ocean by the rainfall. Another source can be the industrial effluents containing mercury that are directly released into water bodies like oceans. There are several types of mackerels, such as king mackerels, Spanish mackerels, Atlantic mackerels, and Pacific mackerels. They all have different average levels of mercury, and the highest one can be found in king mackerels, which has 0.730 ppm or parts per million or micrograms per gram mercury according to the US Food and Drug Administration. Is it still safe to eat them? Is there a maximum safe dose of mercury? In this case, we can use the safety standard by the US Environmental Protection Agency, called reference dose or RFO. The RFD indicates safe daily consumption of substances in unit of body weight each day. The RFD for methyl mercury is 0.1 micrograms per kilograms of body weight per day. To put it clearly, let's do an example here. Suppose that I, a 60-kilogram woman, just ate one serving or 170 grams of king mackerels. The mercury in mackerels would be 0.720 microgram per gram times 170 grams, which is equal to 124.1 grams. Micrograms. My RFD, or safe daily consumption of mercury, would be 0.1 microgram per 5 kilograms times my body weight, 60 kilograms, which is equal to 6 micrograms. See that the mercury I just consumed exceeds my safe threshold of mercury consumption.
In terms of battling this container issue, we Macmerrel are delighted to introduce our solution that we believe could be beneficial to our community. How's that so? Let's take a look.
The idea is to track down the presence of mercury in mackerels. Of course, it's really hard to know every single exact mercury amount in mackerels, which has become one of the challenges that we face here. Therefore, our goals is limited to sample one fish only per mackerel shoal because they often share the same feeding area, so we can assume that they have similar amounts of mercury per group of mackerel. Our workflow is relatively simple. As you can see here, we have our mackerel, and to make it possible for sampling, the first step is to mash down the mackerel. Then we can add or drop our biosensor, and the last part is we're gonna take a look at the red light that will indicate the presence of mercury in the mackerels, which we can see through a fluorescence microscope. So our biosensor is using a chassis of Escherichia coli, or widely known as E. coli, one of the most commonly used chassis, thanks to their fast and inexpensive growth. And for those who are not familiar with the term of chassis, so it's a cellular host used as a recipient of engineered biological systems in synthetic biology. And we also have a term too for the engineered biological system, which is known as plasmid. The plasmid will act as a delivery vehicles or factors to introduce foreign DNA into bacteria. And the plasmid is introduced into bacteria via a process called transformation. The plasmid that we use for our project contains this part that we took from agent parts. Okay, the first one. Here we have a constitutive parameter. It is a parameter that is considered to give stable expression levels across varying culture conditions. To put it simply, it will always turn on no matter what the condition is. For our biosensor, we use parameter J23119, part of Anderson parameter family. It makes RFP or red fluorescence protein. In this case, we use MJ as the downstream of the parameter. And the main character here is merr, a mercury responsive transcription factor. So when mercury is available in the environment, the ions will bind to the interface of the merr dimer, and the Hg-bound merr can result in a structural distortion of polymerity. You guys can see here a mercury responsive promoter that allowing the RNA polymerase contacts to be made, leading to the expression of downstream genes. In this context, we use mCherry, as I've mentioned before. And yep, mCherry itself is a red fluorescence protein, RFP, that belongs to a group of fluorescence protein chromophores. It works as an instrument to visualize genes and analyze their functions in experiments, which in our case, in our project, is to express the presence of mercury. Henceforth, there are two possible outcomes of our project. Yep, it's either we're gonna see the red light or there's nothing at all. The red light indicates the existence of mercury in a way where the brighter the red color is, the more amount of mCherry is expressed, which is directly proportional with the amount of mercury in the fish, in the mackerel that we are experimenting with. Yet, when there's no red light emitted, we can conclude that the mercury doesn't exist.
Okay, now we do not mean to persuade you to no longer eat mackerels. Instead, aside from doing this as a form of participation for the Ajang Indonesian League, we hope that our ideas can be beneficial for the fisheries industries. A new innovation, perhaps. It can be a foundation for further research so that it can be implemented by the industry to locate areas of oceans that are contaminated with high and low mercury. As for the publics, we hope to raise more awareness about the food that we eat and its sources. We also hope for the publics to care more about pollutants and the things that are happening in our environment. At last, we aspire that our project can motivate more and more young people to dwell on scientific biology or other disciplines of natural science or social science, whatever we're eager about, and use the knowledge to come up with creative solutions to our world's problem.
Thank you for watching, and we're ready for Ayo ikut Ajam. Ayo ikut Ajam.
Ayo ikut Ajam.
Ayo ikut Ajam. Ayo ikut Ajam.
Ayo ikut Ajam.